Alright, boys and girls, let's move on to the next chapter in our lab book, and it is, might be scary to some, but if you keep practicing, it's really not that bad, and that's what we're here for. It is Eigrp for Ipv6. As I said in some of the other chapters that we've been doing here, that's one thing that Cisco has kind of moved toward in the 300-101 CCNP route. Instead of the older versions in 642-802, they kind of threw Ipv6 into the end of the book, so you had to deal with all kinds of Ipv6 at the end of the book after you've already pulled your hair out trying to remember all of the other stuff that you have to cram into that cranium. So they kind of sprinkled it throughout the route book and the lab, so it makes it a little more palatable, if you will. So this is the first one we hit, and it's lab 2-3. So as you can see here, we already have our topology set up here, and just to save time, I already applied the addresses to all of our interfaces here. I can pull one of them up here so you can kind of see how we have it set up here. So as you see here, to set up our IP address, we don't do IP add and put our address in. We have to do Ipv6 address for each one. So we have it here, which are all documented out on our topology. And also we have link local addresses set for all of our routers. And this is applied to all of the interfaces, so the fast Ethernet interfaces as well as our serial interfaces all have the link local address set, which you can see here, Ipv6 address FE80::1234, and then a link local command behind it. And then we have our regular address here for our actual serial links and our fast Ethernet links. And that is pretty much where we are at right now. We also have some loopback addresses applied to router 3. So nothing too tricky yet. So now that that is set, we're going to actually enable Eigrp for Ipv6. And this is slightly different than the Ipv4 Eigrp version, because with Ipv6 Eigrp, you are actually going to be enabling this through the interfaces themselves instead of doing a router Eigrp, whatever process number you give it, 1, 100, whatever, and then giving network commands and then allowing it to advertise out from there and establish their adjacencies and go through it that way. So essentially the way we're going to be doing this is we'll go to each interface and enable the Eigrp for Ipv6, and by doing it per interface, it'll also say this network that is connected to this link is able to be advertised. So that's kind of takes place of the network commands. Let's give you an example here. So the first thing we need to do is we need to enable the Ipv6 routing. And to do that, we do Ipv6 unicast routing. Hit enter. Now that's ready. So now we can do our command to get into Ipv6 Eigrp. So what we need to do, in order for this to work, we have to have a router ID. Some other little caveats here, and then we'll go to the actual interfaces. So the caveat is, in order for Ipv6 Eigrp to work, we have to have a router ID. And what's even stranger about it is it has to be a 32-bit address. So we have to use this address and put in there to get it to come up. If we just go in here and do Ipv6 router Eigrp1, some of the code, if you do it older than 15.2, you actually have to give it a no shut command. Just a little FYI, if you're using an older version of code. This one I'm actually not, so I won't have to use this no shut command. But if you do that and don't give it a Eigrp router ID, it's not going to work. So it won't establish JCs, it just won't do anything. So I'll go back to it here, and we're going to give it our router ID. Router ID, and we're on router 1, so we're going to give it 1111. Now let's go to router 2. We're going to go right down the line here. We're going to do IPv6 unicast routing. Now we're going to do IPv6 router Eigrp1, and we're going to do Eigrp router ID 2222. Okay. I go to router 3. IPv6 unicast routing. IPv6 router Eigrp1. Eigrp router ID 3333. Okay. Now that is set up. So now we're ready to start applying the Eigrp IPv6 to our interfaces, and then from there we'll start to see adjacencies coming up. So what we'll do is, let's start with, I'm going to move this down here so we can kind of see multiple routers running. Alright. We'll do it here so I can see my... Yeah, there we go. Alright. So router 1. Let's start with F00. Alright. So we're going to do simple commands IPv6, Eigrp, and then your process ID. In this case, it's 1. Okay. Now we need to do it through our serial interface, so NS10, IPv6, Eigrp 1, and that is it. So now let's go over to router 2. Shrink that down right there. Alright, so let's go int F00, IPv6, Eigrp1, and S11. Now we should be ready for our adjacency to come up here in a second as soon as I apply the next one. So we'll go to int S10. This will give our adjacency to router 1. The IPv6 5. Eigrp 1. And there's our adjacency. And you see here, Eigrp IPv6. And it's given the neighbor based on the link local address. FE80, we have FE8002, which is router 1, router 2. Back up here. Alright. So we have our first adjacency. So now we need to go into router 3, and we'll get this guy up. We'll close router 1 out. We don't need him right now. And we'll move this over here so we can see some more adjacencies coming up. So router 3, we need to go to int S. Let's go F00, IPv6, Eigrp1, and we'll go to, let's do our loopback addresses here. So we have 1, 2, 3, 4, 5. So let's do an int range to make this a little bit easier. Hello 1 through 5, IPv6, Eigrp1. Let's go to int S11. IPv6, Eigrp1. We get another adjacency. So now we have 1, 2, and 3 are all up talking to each other. Okay. So let's go to router 2 so we can see both of our router adjacencies here. Let's do a show where it gets tricky. Instead of showing IP EIGRP neighbors, we have to remember we're running IPv6. So IPv6 EIGRP neighbors. If I can type. And I get out of config too. Show IPv6 EIGRP neighbors. There we go. So we have our two neighbors. We have FE80:3, which is our link local for router 3, and FE80:1, which is our link local for router 1. So there we go. So we have two adjacencies up. And let's try to heck out of it while we're in router 1 down here. Let's see if we can ping across. We should be able to ping. Let's go to, see if we can ping this guy down here. Switch to is 2001 DBA Cafe 5. Pinging 2001 DB8 Cafe 5 colon 1. There we go. So we're pinging across, so we should be good. And some other commands that we need to keep in mind is the basic commands that we used to do: show IP route. It's all, instead of doing IP route, we need to do show IPv6 route. And let's look at the EIGRP. Come on. Not router. Route. Work, fingers. There we go. That's better. Alright, so as you can see, we have a bunch of IPv6 addresses here. These are all in EIGRP. We have ABCD 1, 2, 3, 4, 5. Those are our 5 loopback addresses on router 3. We have Cafe 3, which was the switch up here, hanging off of router 2, I believe. And take a look here, see where all we got. Yeah, there's 3. Cafe 1. Alright, so we have all of our networks there. So we have a full topology here. And looking at our lab book, there's a question that comes up, and one of them is actually kind of dumb. It just asks, why are there no feasible successors? So if we do a show IPv6 EIGRP topology, we're going to let this, there's no feasible successors. Why is that? Well, it's pretty simple. We don't have any other ways to get to these routes. But we have to go through router 2, so there is no other feasible successor. There's no other routes to get there. So it kind of answers that. Another question asks, why are there 2 more entries in the EIGRP topology table than there are when displaying the routes through the IPv6 route EIGRP command? So we already did IPv6 EIGRP command here. I'm sorry, we're in topology, so here's our 2 here. So let me scroll this out. Alright, so this time we got 2 more in our route table. Topology table, then the route table. Sorry. Got that confused. I read it backwards. So we have 2 more here than we do here. Why is that? Well, just like in IPv4 EIGRP, if you look at that, you're seeing EIGRP. That doesn't show, when you're given that command, show IP EIGRP route. You're not going to get local or directly connected networks. versus down here, you're going to get those connected networks. So it said we had 2 more. So 1 and 2. So those are your 2 extra. So that answers that question. So the next step that we want to do is we're going to configure the passive interfaces on our fast Ethernet links, just so we don't have additional traffic being spewed across these links that we don't necessarily need. And all we have to do on that, we're going to go into Ipv6 router, Eigrp1, and from there we can configure our passive interfaces. So passive interface F00, and we'll just do this on every router. Pretty simple. Interface F00, and we'll go to router 3. Passive interface F00. Alright, easy peasy. It's not a verify, we can just do a show Ipv6 protocols. We see our interfaces. Fast Ethernet is now passive. Alright. So, I guess our next step would be to configure a summary route, because we're going to condense down our routes. So as I said before, we had ABCD 1, 2, 3, 4, and 5. So here's a bunch of extra routes being advertised, and we can summarize that down because they're all within the same bigger subnet here, and they're right next to each other. So we can summarize this. So same as IPv4. When you look at our binary here, we'll go real quick. Let's do, okay, so we have, essentially I'm not even going to look at the last subnet here trying to spell all this stuff out. So the main thing we want to look at is 1, 2, 3, 4, and 5. So with IPv6, I don't know how much you have read on this already. Hopefully you've already been reading on it if you're trying to lab it already. There's 128 bits in IPv6. So it's 8 groups of 16 bits. So when we do that, we have 1, 2, 3, 4. These are our octet for each individual octet in the IPv6. So it's 16 bits, so 1, 2, 4, and 8. All that combined is 16 bits. Make sense? Good. Alright. So what we need to do is figure out the furthest back we can go to match all of our octets here, our bits, so we know where to summarize back. So we know our biggest number here is 5, which in this would be 0, let's see here, 8, 4, 2, 1. So that is 5. So you got 0, 1. That's 4, and 0 and a 1 is 1, so 4 and 1 is 5. So then we have 4, so 0, 1, 0, 0. And we have 3, 2, and 1, so 0, 0, 1, 1 would be 3. And then 2, so 0, 0, 1, 0. And last but not least, 0, 0, 0, 1 would be 1. So we have 1, 2, 3, 4, and 5. So now looking at this, how far back can we go that actually matches all the same bits, a matching bit? We're all the way back to this first bit. And seeing we're at 64 for our subnet, we need to go back. So 64, 63, 62, 61. So what we're looking at is going to be 2001 db8 abcd ::/61, and that is not supposed to be a star. 8 :abcd : /61. This is going to be our summary address for our loopbacks on router 3. Alright, so let's go to router 3. Minimize those down. Router 3. We'll bring this back up so we have a reference. Alright, so let's go into, as you remember, all this stuff is done per interface. So we need to advertise this out, our interface. So we're at S11. So int S11, Ipv6 summary address, and we're going to put it into Eigrp. Once our process AS number, so 1. And now we need to put in our address, 2001 db8 ab, come on, work fingers, abcd : /61. So I hit that. We're going to resync. And there it is. So we have a resync, and that has been sent out. So let's look at router 1. You recall here ABCD 1, 2, 3, 4, and 5. There we go. So now we went from 1, 2, 3, 4, 5, 6, 7. We had 8 lines in our routing table for the Eigrp. Now we're at 1, 2, 3, 4. And here is our summary route. ABCD : /61. Pretty cool, right? So now we can go ahead and verify. Let's do a ping to 2001 db8 abcd. Let's do : /5. Did I type that right? 1 db8 abcd : /5. Ah, I didn't do the address right. :5 1. Hey, also I typed the address right, huh? And we can do the same thing for : :1, 3 : :1. Hey, you get the picture. 2 : :1. So there we go. So we're pinging across. And I guess the last thing we have to do is let's get a default route. Basically what this is going to be here. Let's get rid of this. We don't need that anymore. Excellent program, by the way, is Notepad++. So if you don't have that, very good to have. I used to do a little bit of programming. And so when you do something like that, it actually highlights all your coding and stuff like that. It tells you where all your stuff is for the parentheses and exclamation points, stuff like that, you know. Anyway, back to routing. So we're going to do a default route. And essentially with this, as you notice, we haven't really done much with router 4 other than we got a few IPv6 addresses on here. So that is set. So what we're going to do is give a default route to this router. That way everything else can essentially get out to quote-unquote to the internet. So we're going to go to router 3, and we're going to point our default route to router 4. And it's pretty much the same way as IPv4, except with this, This is what they call a fully specified static route, because it's going to have a exit interface in it as well as the next hop address. So what we're going to do is Ipv6 route, and this will look a little goofy, but it'll mean the same thing. So when you have all these two colons here, that means they're all zeros. So essentially we're doing 0000 / 0. So a typical default route, we're going to go to serial to 0, which is our exit interface. And then we're going to put down our next hop address, which is over here. So that's 1 db8 feed 77 : 1. db8 feed 77 : 1. Alright? Alright. So now we need to be able to redistribute this through the rest of the network. Right now, nobody else knows about this route. We can verify that. Do show Ipv6 route. Got nothing. And we can get rid of the Eigrp. So we don't have anything. No default route. So let's go to Ipv6 router, the Eigrp1, redistribute static. We'll go back to router 1, and there you go. We have our default route. As you notice, it is showing up as external. So therefore, administrative distance has changed from 90 to 170 because this is a redistribution. So anytime you have a redistribution, unless you change the admin distance manually, it will have a admin distance of 170. I guess essentially we could change it through here and change the admin distance and let it redo it, but for the sake of time, we won't do that. So now we have access to, quote unquote, the internet. So let's try it. Being 2001, db8, feed 77 : 1. There we go. We can get to the internet. The last thing Cisco talks about, even though it's pretty much already working on here, but I'll show you the commands, is the CEF for the routing on here. It notes that the CEF for IPv4 is enabled by default. Sometimes the CEF is not enabled automatically. This is pre-iOS 15.4. So if you're running newer than that, then you're good. You don't have to worry about it. But sometimes the CEF might not be enabled. And if that's the case, then we'd have to enable that. So to verify, we can do a show Ipv6 CEF summary. And right now, as you can see, Ipv6 on here is enabled and running normally. Centrally, I should say. So if we need to configure it, all we have to do is conft Ipv6 CEF. All you need to do. And then from then again, you can do Ipv6 CEF summary, and it'd be enabled. There you go. So just a little tidbit that Cisco throws out there in case you're running older versions of code and it doesn't enable automatically. Just go in there, enable that command, you're good to go. So hopefully this has helped you out. Hopefully it isn't too painful for your first round of Ipv6. It's really not that bad once you kind of get the hang of it, start configuring stuff, and realizing that you do it on an interface level. The addressing is a little more goofy. trying to remember the addresses. So that's excuse me, one complaint that I have. Nothing can be done about it, but say you're used to being able to go to an address on your network saying, oh, I want to go to 192.168.10.2 is one of my servers. And now you're trying, it's easy enough to remember that, but now you want to go to, you go over to IPv6, now you have to go to 2001:DBA:CAFE:3:3 or something. So it's a lot more strenuous to try to get to an address manually, or if DNS is broken, you want to get to an IP address to get to something. It's a little more difficult to do now. But it's kind of nature of the beast when you run out of IP addresses in IPv4. So hopefully this has been helpful. And as always, like, comment, subscribe. Let me know if you have any questions or anything else you want to see. And I'll start on the next video here. It'll be Lab 2.4 for the named Eigrp. See you then.